And I guess we'll just get to our first speaker. So V, if you're ready to go. V comes from the startup world and from the big tech world, and he likes rock climbing. And I won't say anything else.
Well, welcome everyone. Good to see you guys. Welcome to my tech talk. I called it V's Tech Talk. No surprises here. Going to talk about how we moved, twice as fast on the front end. We did that taming our complex backend with TS REST and a Next.js API. Now, for some of you who like to go really, really low level, I'm not going to go that level today. Really, what I'm going to walk you guys through is some just useful things you could probably bring to your project. And I just kind of put myself in the seat of a developer who's working on a side project or something that you want to ship out and kind of move fast on. That's kind of the main point of this talk. It's just to help you guys, give you guys some real in the trenches advice in terms of what worked for us to move really quickly on shipping a product. Cool. And how many people in here today are developers? Probably everyone, right? Okay, sweet, good, I'm right audience. So a little bit about me. Co-founded an AI audio startup called Adauris. Did that for about 5 years. It actually got acquired earlier this year. I went on to become head of engineering at YGG. It's a crypto startup out of SF, and then I was managing a bunch of devs. And then recently just joined Microsoft 3 days ago, so I'm super fresh. Yeah, so what I'm doing at Microsoft, I'm a senior solution engineer on the cloud and AI team, and focusing on dev tools. So I kind of sit actually in between Microsoft and GitHub. All right, so we're going to talk about the topic, how we moved a bit faster on the front end and back end, really. We did that, taming our complex back end, and you know what the solution is, but it's really not about the destination. It's going to be about the journey in terms of how we got there. So, quick note. I love memes, so there's going to be lots of memes in this. I do recognize that there are devs who are very passionate about frameworks and the right tools and things to use. So by no means, what I'm suggesting is a silver bullet for your architectural decisions. This is more about what fit for our very specific requirements with the specific skill sets that we have. So hopefully no one erupts in a brawl before heading to road today. All right, so to kind of level set things, we had a backend that we were working with. This is the architectural diagram that's super simplified. I didn't want to overwhelm y'all here today. But basically, we were working on a different product, and we had a backend that was going to support that. So we thought we were going to do one thing, and we had a really great backend that was going to support that at scale. It was a custom event bus system with a CQRS pattern, and it was to really support 100,000 users that we were going to expect. And then we realized, not that we realized, we had a bit of a pivot, that we were going to do an entirely different thing, and it was really more of a V1 thing that we were going to do. So when we were working on this new platform, we fell behind quite quickly because the product requirements kept changing. This complex event bus system with the CQRS pattern and the number of layers that it had, it was 7 to 10 layers that we had to kind of shift through for a very simple code change. And so we were about 3-ish weeks or more behind on schedule. We realized very quickly that this was not going to get us to the finish line. So we had to kind of do an investigation and look at how we were going to get there. The big thing was that the tech stack that we had didn't support the need for us to keep up with the business pivots. So I'm sure some of us have dealt with pivots. I love Lord of the Rings, pivots, product and engineering, cast it into the fire, destroy it. The business stakeholder, maybe the CEO, no. I mean, show of hands here, who's dealt with pivots, and many of them during a project? Not as many as I thought. Well, I'm sure you guys have all dealt with it in your projects, or whether you're working at a startup, you have to keep up with new information that's coming in, especially if you're working on a small project. So that's the main requirement here as I go through this journey with you guys. All right. So we looked into 3 options. Well, there was actually many more that we looked into, but I think what's going to be relevant here today in terms of knowing the type of audience that's here and the type of projects that you guys will engage in, I think these are the three that I think are worth exploring a bit deeper on. So we looked at tRPC. We looked at a traditional REST API that's decoupled from the backend or decoupled from our app, and then obviously TS REST. And then I'll walk you through this journey in terms of what this looked like. All right, so let's start with option one, tRPC. How many here have heard of it before? Yeah, a lot of people, exactly, yeah. It's a pretty well-known framework. It's great, it's fantastic. You know, it just depends on what your project needs are. We really liked it, but basically it provides like end-to-end type safety, and there's a lot of different adapters that it has. So whether you have like a React project or a Next.js project, it's quite flexible in terms of what your needs are, but effectively as we're coding, as you can see here in your server.ts on the top left, and then your client.ts here, you can see that you can get end-to-end type safety between your front end and back end code. So this is what it looks like through Jiffy. I'm going to keep this really high level. I mean, there's a lot of different things that I can dive into. But as you can see here, when you're declaring a certain, we'll say a data type on the back end, and then you're using Zod for type safety as well, if you're trying to make a change in the front end, it's going to catch it right in your IDE that you're not able to or fetch that piece of data. So it's really powerful, and it catches bugs before you ship stuff, which is really, really powerful framework. Again, great companies using it. I believe Google's using it, Netflix, there's a few other companies top of my head, but there's a lot of great companies that are using it for certain projects. So, I mean, overall, this is what the architecture looked like for our specific project. We had a platform monorepo, so it was one GitHub repo. We had a Next.js app. We had two of them in there, but we'll focus on the main platform app, as you can see there. And then we had front-end components. You have your tRPC backend and router. And then there was a shared Prisma package in the monorepo. And then again, it all sits within one repo. So this is what it looks like. Now, my question to you guys, and I'd love to hear from y'all, so don't be shy. What do you think the trade-offs are here looking at this? And what do you think the biggest risk is? Scale? That's a good one. It's a very, very good one. There's lots of devs here. Don't be shy. Use your big brains. There's so many brains in this room. At that being a risk of monorepo? I mean, all the options were effectively a monorepo, but it is an issue, specifically a monorepo with the front-end app, so yeah. Learning curve is a big one, absolutely. Also a very good one. I didn't actually list it in the next slide, but that is a good one. Exactly, exactly. Yeah, so there's some like developer experience issues for sure. I mean, pros on developer experience as well, and then there's some cons with that too. And then deployment is actually a big one. Yeah, great stuff. Went straight to pros. There are some pros. Okay, so you do get end-to-end type safety, like that is a thing, depending on what the needs of your project are. You don't need separate API type definitions, which is very powerful. Again, very easy to use in terms of if your stack is TypeScript and your developers are familiar with it. Solves for under and overfetching issues. Can be good for monorepos, but again, it really depends on the needs of your project. But in terms of all the cons, which I'll get to, which I didn't actually list at all, those are some things that we did take in consideration of. In our case specifically, there was one con that killed this idea. And that was because it was super tightly coupled architecture. Now, why is this a problem? Well, you saw our backend. The first version of our project that we had, it was a CQRS event bus system. And we knew that, okay, by V3, V4 of this project, we want the backend to be decoupled from the front end. If we use tRPC and all of the code is super tightly coupled all the way up to the front end components, it's going to be really hard to migrate away from tRPC. So because of that reason alone, and we knew that was going to be a monumental effort, we decided to, this was just not it, because we knew by V2 or V3, we wanted to have a separated out backend or some composable microservices out of it. So because of this one reason, it was basically a non-starter for us. All right, so let's jump into the next one. Option 2. This is no surprises here. I think all of you guys have done some project like this, or most of you, where you have a front end. Right? If you look at the architectural diagram, and there's a REST API. In our case, we were looking at an Express app service that sits in Cloud Run as an independent backend. I think this is a pretty common architectural pattern. Again, it's a solid choice. If you go with this, honestly, it is still a solid choice. There are some things that we were looking for in particular, but I'll stop here. What do you think the trade-offs are here, and what do you think is the biggest risk? Exactly. That's a big one we were looking for. That's a good one. Bingo. That was a big one. We looked into different packages. I know I just listed Prisma package here, but maintaining that was going to be kind of a pain in the butt, especially if it's in a different repo as well. Because then you have to set up. Anyways, yeah, it's a whole DevOps thing, and it's really annoying.
Developer experience when you have to set up all this stuff.
Yes. Yes. Yeah, maintaining like 2 different environments, and you have to maintain your environment variables for your next app, and then you have to align the environment variables for your backend app, and it's just kind of a pain. And that's where all the bugs were coming from as well for us. Yeah?
Typical problem for REST is overfetching or underfetching.
Exactly. Yeah, that can definitely issue. We weren't as concerned about that one in particular, but that was something that we were looking at as well. Any other ones? Okay, well. Let's talk about pros. Again, it is decoupled, so if we wanted to, say, move away from an Express app service and then move to our event bus CQRS pattern, it becomes a lot easier because it's already a decoupled service, and the front end, the only layer that we have to change on the front end when we're doing data fetching is the service layer. Right? The back end is decoupled. If we want to spit things up to microservices or whatever that might be, we had that flexibility. So in terms of level of decoupledness, it's great. And yeah, I mean, there's obviously a argument for better infra scalability, but it all depends on how you set things up. On the cons, I mean, I didn't list all of them. I didn't have enough space, but all the things that you guys mentioned definitely should be up here. Just developer friction, so spinning up the front end and back end to what you were saying, definitely was something that we really wanted to avoid. I mean, the issue that the devs were having, just to put in perspective, we had devs where one team was trying to build some features, and then they had a set of environment variables for the front end that were slightly different from the back end, and then it was just all these bad assumptions, and it was just fighting that battle with 2 different environments was just really slowing us down. It was just really painful to go through. And then no inherent type safety. I think someone said something about that right at the beginning. Wherever you are, thank you, because you were correct. Yeah, cool. Oh, and increased DevOps infra management. Think about it. If it's not a unified app, not only do we have to worry about deployments with our next app, we're going to have to worry about deployments with the Express app or whatever it is and all of its dependency services. So there's this whole DevOps aspect to it too, which you don't really think about at the beginning of the project. As soon as you ship that first, version 1 out, DevOps becomes a much meatier thing. Okay, well, that brings us to option 3 today. Build your V1 app one faster. Not a lot of people. You talk about TS REST, and there's a room full of you today. Well, it wasn't just because of this, but I like this game. So if you look at this architecture here, we wanted the safety of tRPC with REST, or the architecture of REST. Wasn't so much because of the architecture of REST, it was the level of decoupleability that we could get with TS REST in particular. So if you take a look at this architectural diagram, it's the same thing. You've got your platform mono repo, you've got your front-end components, and then you've got your API routes. Then your API routes types from, I really should have changed the background of that component at the bottom, because it's really hard to see. But it says datacontract.ts, the bottom right square. So your front-end components, and then your back-end code in your Next.js API folder, all types from that one particular file and its child files called the contract.ts file. Now, before I actually go any further, who has worked with a Next.js app deployed on Vercel before? I'm actually really curious about that. A lot of people. Okay, most people in the room. So there's two caveats that you should probably know about with Next.js. So when you're in Next.js, there is a special folder. So it's an at its root, it's an opinionated framework around React. In a special folder called /API, it's where you can put backend server-side like calls or server-side like code in. Now, when you deploy your Next.js app onto Vercel, every subfolder in your /API folder, each of them gets deployed as a microservice on Vercel's infrastructure. So each of them is like basically a Lambda. It's an AWS Lambda. So if I deploy a bunch of code on /API, we'll call it /v1, /post, /books, and so forth, each of those subfolders that I deploy will all be deployed as a backend serverless function. So this is a really important caveat for you guys to know before we proceed further. Now, okay, let me just walk you through what is TS-REST and what does it look like at a code level. So looks very familiar to what we looked at with TS-REST. So, or excuse me, with tRPC. You get that end-to-end type safety. You can see here in contract.ts at the top, you declare your contract. You can put in your method, path, responses. You can use Zod for that type catching, and then a summary. And if you look at your /pages at the bottom, so with the post router, you can see that it's getting that data that you need from from the contract variable. So more specifically, if you look at this other example, you can start to get a little bit more creative. You can have subfiles where you can declare certain schemas, query schemas, response schemas for your responses. Again, this is all happening at a middleware layer for your next app. Now, if you look at the front-end code, so you got your lib API client.ts, it's importing from contract, so very similar how to the backend endpoints of Next API is importing from contract. So as you can see here, you can zoom in a little bit closer on /components. This is a super simple example. In my component, you can see with the data fetching, client.getPost.useQuery, post one with the params, it's all getting the same type inference, end-to-end type safety that the backend endpoints have. So it's very much that tRPC feel, but it's still fetching the data in a decoupled way. It's not as tightly coupled as tRPC, but you get that same benefits. So again, this is a very, very simple example. And this is what it looks like when you piece it all together. I'll pause here. Any questions on these code snippets so far? Yeah.
It's so similar to tRPC.
Yeah.
Isn't it not still bound? Like you're still client and server are still dependent on each other.
Exactly. So in some, yes and no's, because you get that end-to-end type safety, like I mentioned. That contract.ts file is the really middle there that catches things. But in our case, we had a bunch of CRUD operations that we needed from our backend. The way you design your backend and the way you design your front-end code for data fetching, it allowed us to also add in those endpoints at the service layer at the front end to put in additional endpoints. Because if you use like a remote procedure call like tRPC, you can't easily eject out other endpoints or input them in as you need. So it gives you that flexibility. It still has that coupling, like you're mentioning, but it's not as tightly coupled.
A little more flexible to do V2 and V3.
Exactly. Because in our next app, there was actually, so most of our endpoints, like 90% of them, were all private. So doing CRUD operations, creating a user, updating some information. We actually had partners that depended on data. So we had these gaming partners. So when a user completed a quest or an action that happened outside of our platform, the gaming partner needed to send that information back to us. So, I mean, not the best practices to do it this way, but we needed to move quickly. So we could actually expose some public endpoints from our next app, and they were able to hit that through a sort of REST method. Now, if we were to use tRPC, it's a little bit harder to do that.
How do you manage state?
Good question. We used, for the front end, well, for the back end, we had some server-side cookies, and then for the front end, we used, gosh, what is it called? TanStack. There's a hodgepodge of things. I mean, I think there was definitely some optimizations we could have done, but we mostly use that framework. Yes, definitely. Yeah, because exactly. I'm going to get to that in a second. But the cold starts were sometimes a bit of an issue. I think when we launched, literally that week, Vercel had launched a new feature called fluid serverless functions. So the cold start times were dramatically decreased. There's this whole documentation about it that you can probably read because I probably won't explain it very well. But there's a new feature that we turned on called fluid compute, so that decreased the cold start times, but it's definitely an issue for certain things. Yeah, that's a great call out actually. Nice. You getting this so far? Am I going too fast? Any questions? You can stop me anytime. Cool. So let's talk about pros with TS REST. Like I said, it's end-to-end type safety, RESTful by design, which we really liked, semi-decoupled, and really a great developer experience. We could seed our local database. We're using Supabase. We can run a seed command because it's connected to Prisma, and we could reseed it as many times as we want, and a front-end developer or a back-end developer could easily just run the whole front-end and back-end and do the CRUD operations as they needed. It was a really, really smooth developer experience, and so this is why we went with it. Now, I could go on and on about why we loved it, but there are some cons, and I think it's really important for you guys to know what the cons are if you're going to consider something like this. All right, so you kind of alluded to the cold start times, which was a really good call out, and that was the biggest thing for us, which is related to that, and that's the serverless limitations. So because of the serverless nature of like the Next API routes, there's actually very stringent infrastructure requirements, meaning that you can't have long-running jobs on serverless endpoints from Next or that are deployed in Vercel. So if you have like workloads or like cron jobs that need to churn through a whole bunch of data that's going to be more than like 30 seconds or 60 seconds is the max, this is not the solution for you, because if you're going to be heavily dependent on like a Vercel, Next.js like API backend for that, this solution definitely won't work. Now, if you're just focusing on like normal CRUD operations where it's fast response times, then this is something that would definitely work. But long-running jobs, this is not something that I would definitely push on anyone. And then there's still some architectural coupling. I mean, you were just talking about it a moment ago. You had some good questions there. And so yeah, it's significantly less decoupled than tRPC, but there's still more coupling when you compare it to a traditional REST backend that's deployed on an Express app. So that is something to consider. And there are some security concerns if you don't set this up properly. If you expose certain endpoints in your Next app, you have to be very, very careful. And so there's a security component as well. And then the two small things here, really, I mean, not big things, but it's a little bit of a learning curve to kind of wrap your head around like end-to-end type safety and setting this up. And then it's definitely a smaller community compared to tRPC. But it shouldn't stop you if you want to use something like this as well. Also a good question. Yeah, I mean, we are spending up quite a bit on Vercel if your project goes to scale, but that was more of an afterthought. We were ready to like spend whatever is needed to, to get the product out fast. That is a consideration. Priority was speed. If you want to have a cheaper solution and not pay the extreme high premium bills that you would get on Vercel, you would want to deploy a separate backend REST Express app on something like Cloud Run or something on AWS or whatever that might be. So cost is definitely a factor if you're thinking about that. But if you're deploying a V1 product and you're only expecting like a couple thousand users, or even less than that, or 100, like it's not something that shouldn't be a deal breaker at all. All right, and there was another advantage actually, which doesn't really apply to just TS REST, but I want to ask you guys this question here. We're all using AI to code. Now, for those of you who use Copilot and like AI IDEs, what is the most common reason for you when you're using it that gives you like a weird or like wrong suggestion? Bingo. Lack of context. Nice one, Can. Yeah, no, that's exactly it. So by co-locating everything, We gave our AI IDE significantly better context with minimal extra setup. And so when we were trying to catch issues in the front end or back end during development, it was actually a lot more effective. Because when we were using our CQRS event bus system, which was in a different repo, when you're coding front-end components in one repo and your AI IDE doesn't have context, or that backend code sits in a different repo, it's going to base it off of a lot of assumptions. If your README in there is not correct, it's going to give you bad answers or not going to be nearly as effective. So being able to actually co-locate your front-end and component, your front-end and back-end code together can be really, really powerful. So this was also another pro that we saw and this applies to both Cursor or like Copilot. The code gen became a lot more effective, better, faster debugging. The refactoring was a lot easier, and a developer could do end-to-end feature development. So when we're developing a feature, like before, the pattern was we had a backend dev that focused on the backend part of the system, and then we had a front-end dev that focused on the front-end part of the system, and they would maybe talk to each other a couple times, and then a couple PRs would go up, and you got to merge them together. In this case, because everything was co-located all together in one repo, it became just so much more easier to do all these things like code gen, debugging, and refactoring as well. I'll pause here. Any questions on this?
Yeah, I think if you, for example, if you use that REST pattern, you can still put the front end and back end in the same folder and do the same thing that you're doing here.
Totally. Yeah. So that's a great caveat. You can also do that. It works, and like we had another backend service which we were doing. Because that folder had its own set of rules as well and had a different coding pattern, it was better than having it in a different repo, but much better, significantly better, but still less effective than co-locating it in the same sort of paradigm of end-to-end type safety. Because having that data contract.ts that you can reference when you're talking to Cursor, right, plus the front-end component, plus the back-end route, becomes a lot more effective. So we talked about a couple of options, talked about some frameworks, I showed you some code, and the question is, what is the result? Well, we shipped. It was a 4-month project, 4-month-ish. We had 3 major pivots with many smaller pivots along the way. Within the first 5 days, we had thousands of users sign up. We had about, I think by end of the first, I think it was like 1.5 weeks in, we had 12 million YGG staked on our platform. It's a crypto thing. A lot of usage, and we had 50,000 quests done. Quests are basically a way where if you do a certain action on a gaming partner that we had, you go and do it, hits our backend API route, we validate that the user killed 20 enemies, and then we reward them in crypto. We had 50,000 of those done in the first 1.5 weeks, and then all of this was running on TS REST and our Next API, and I was handling the workload quite well. So we took this to not like crazy scale, but pretty good usage ultimately. And so yeah, this was the result of like using this backend framework. And I think, with the team and I talked about this, if we hadn't made that choice, and if we had stuck with the original architecture that I showed you at the beginning, I just don't think that we would have shipped on time. I just cannot imagine having us have done that. So I'm really glad that we made that architectural decision. Now, as usage goes up, cost is becoming a factor. I mean, we're spending like $1,000 on Vercel now, or like $700 a month. It's not crazy, but we're spending nearly, I think, 1,000 or 1,000 something. So cost is becoming a bit of a thing. Our API routes, I think they're getting hit like a few million times a week as well. So we want to spit those out into microservices. But because we're on TS REST, we can spit those out into microservices. If they were as tightly coupled on tRPC, that wouldn't have been easily been possible. So we are marked safe from not shipping on time. No, sorry. Yes, shipping on time and tech debt mostly. And then last meme of the day for all of you guys. Walking, running, sprinting, TS REST plus Next.js API on a V1 platform. And thank you very much to all of you for coming to my TED Talk today. Yeah.